Now continuing further on bisectors, in the previous video we had formed the rules for finding the bisector which was acute angled or obtuse angled. Now we'll explain this. Suppose these are your two lines and let's say these are your two bisectors, the equation of which you can easily find out. Now if this is acute angled, this is acute angle between L1 and L2, that is, let's say if this angle is 2 theta. Now if 2 theta is between 0 and 90, why? Because this angle is acute angle, it should lie between 0 and 90. Now this line, let's say this is B1 and this is B2. Now what would be theta? Theta would be what? Between 0 and 45. Now if we take tan, it means tan theta should be less than 1. And what is theta? Theta is the angle between the bisector and the line. Whether you take this angle or this angle, both are equal. Whether you take the angle between bisector and line L1 or bisector and line L2, if that value, if the angle between these two lines comes out to be less than 1, then obviously this bisector is what? The acute angled bisector. Now if 2 theta is acute, then this is acute angle. Now this angle is what? 180 minus 2 theta. And since this is obtuse, it should lie between 90 to 180. Therefore it means what would be this angle? This would be half of this, 90 minus theta. So taking half of this, what we get? 90 minus theta is less than 90. Now if we take tan 45 is less than tan 90 minus theta. And what is 90 minus theta? 90 minus theta is the angle between the bisector and the line L2 or L1, whichever you might take. And what is tan 45? 1. Therefore tan 90 minus theta, which is the angle between the bisector and the line, should come out to be greater than 1. And this is what we had done when we explained this. You can take any line and any bisector and find the angle between them. If the bisector you have chosen is an acute angled bisector, then the angle between any line that you have chosen, L1 or L2, and the bisector, its tan theta should come out to be less than 1. And if the value is greater than 1, then the bisector that you have chosen is the acute angled or is the obtuse angled bisector. Now let's take an example on this. Let's say we continue our question that we had taken. Let's say we have this question. Let's say we have this question. Suppose, let's say we find the equation of the angular bisectors between the lines this and this. Now this we have already done. The bisectors that we found out were, we can find out x plus 8y is equal to 4 and 56x minus x plus 8y is equal to 4. X plus 8y is equal to 4. This was your first bisector, and the second one was 56x minus 7y plus 36. 56x minus 7y is equal to 36. This was plus 36. Plus 36 equals to 0. This was your second bisector. Now we are interested in finding out which bisector is acute angled and which is obtuse angled. Matlab which bisector is bisecting the acute angle between the lines and which bisector is bisecting the obtuse angle between the lines. So what were our steps? Assume any of the lines. Let's say we take 4x minus 3y plus 4 is 0 and take any of the bisectors B1 or B2. Let's say we take x plus 8y is equal to 4. Now you have chosen one line and one bisector. Now find the angle between them. What is the angle between them? For finding the angle between the lines, we need m1 and m2, slopes of the lines. m1 is what? Minus coefficient of x upon coefficient of y, that is 4 by 3. What is coefficient of x? 1 minus, and coefficient of y is 8. Now apply the formula. Angle between these lines tan theta is what? m1 minus m2 upon 1 plus m1 m2. What do we get? m1 is 4 by 3 minus of minus 1 by 8 upon 1 plus 4 by 3 into minus 1 by 8. What do we get? We get 4 by 3 plus 1 by 8 and 1 minus 4 by 24. If we take the LCM, we have 8 4 the 32 plus 3 upon 24 divided by 24 minus 4 is 20 by 24. What do we get? We get 35 upon 20, which is 5 7s are 5 4s are. This is 7 by 4. Now what we see is the angle between the line and the bisector is what? 7 by 4, which is greater than 1. That means the angle is greater than, the angle between the line and the bisector is greater than 45. It means the bisector that we have chosen is the obtuse angled bisector. That is this bisector. This bisector. This bisector is the obtuse angled bisector. Obtuse angled bisector. And obviously the other one, this one, becomes the acute angled bisector. This becomes your acute angled bisector. This is how we find which bisector is acute angled and which is obtuse angled. What was the step? Assume any of the lines between the two, assume any of the bisectors, and find the angle between the line and the bisector. If the angle formed tan theta, the value of tan theta is greater than 1, then the angle between the line and the bisector is greater than 45, which implies that the angle between the, which implies the bisector that we have chosen is the obtuse angled bisector, and the other one becomes the acute angled bisector.